Today we're going to go over single-stream machine environments and mill-turn environments. Single-stream environments and mill-turn environments are different. A single-stream environment is generally a lathe with a C-axis or a combination of a C and Y axis, maybe a sub-spindle. A mill-turn environment usually has multiple turrets or a spindle head and requires turret synchronization. We have many different mill-turn environments from different brands. We have over 416 of them, and they're growing every day. So today's demo, we're going to go through project setup, operation, the sync manager, and the machine simulation. So with that said, let's get started. It's a typical part you probably see lends itself well to a mill-turn environment. It's mostly round, has some flats on it, some angles, some holes. So now that being said, it's brought in, it's already orientated the way we want it. So the first thing I'm going to do is I'm going to grab the machine environments. We're going to start with the Mazak Integrex I200ST 1500U. First thing that's going to pop up is your job setup. It gives a description of how the machine's laid out. So I have a left spindle with an 8-inch chuck, default jaws, and a right spindle with an 8-inch chuck and default jaws. Maximum RPM, 5,000 RPMs on both sides. So now we'll go with setup type. I'm going to start this job in the left spindle. I'm going to do a continuous bar pull, pick off, stock pull, and cut off. Start in the top plane. I'm going to select my solid for the geometry. It'll place my part even with the vice jaws, with the chuck jaws. It'll create another solid on the other turret, on the sub turret, 100 levels away from this one. I can create a turn profile if I want to use wireframe. Today I'm going to use solid for chaining. I'm going to go bar stock. Since I'm in continuous pull, I'm going to add 3 to that so it adds length to my stock. I want to add a little extra on the faces, 50 thousandths on the front, 50 thousandths on the back. Set my Z origin to the right side. Work offset, G54. Set my stick out. I'm going to grab the end of this part. And then I'm going to add 250 thousandths to it to pull it away from the jaw so I can part it off. Go to the right spindle. I'm going to set it up. The left face is our Z origin. G55 is our offset. Pick off. I'm going to pick a point on the part. So let's pick here. It's about 2.5. So let's add a little bit more so it gets it away from the chuck a little bit. So 750. I'm going to tell it my cutoff width. I'm going to set it at 125. I'm going to go grab a tool. Go to my library. Grab my library. Grab my part off tool. If you don't pick your part off tool, Mastercam will create one for you. I'm going to green check this. It's going to create some view planes. It's going to create some planes for machining. The view planes are set to left, but they don't always come in exactly the way you want them, so you can fine tune them. I don't want to see the right stock when I'm working on the left side, so turn that one off. Then I will save that view. Click on the right side, same thing. I don't want to see the left stock when I'm working on the right side. So we'll save that. When I look at both, that looks fine. So let's start out on the left side. We'll turn on the shading so you can see the stock. Now, with the setup complete, we can start throwing toolpaths on this part. So we'll start out with the face. Select a tool from my tool library. I'm going to use the upper turret for this one. And out of the get-go, it's set at radial. And I want it to be in diameter, not radial. So I'm going to change that. I'm going to orientate my tool. Since it's facing this way, I have to rotate it down 90 degrees with the B ahead. And I'm going to manually define my cutting edge to put it into this quadrant here. Facing parameters pretty generic. Using stock, we'll adjust some of my feed ins and feed outs, or my lead ins and lead outs. Nothing real spectacular here. So we've got a facing operation. So now I want to do a roughing operation. I'm going to use the lower turret for this. So as soon as I pick a chaining, I pick that operation, it kicks me into chaining. And you can see the solid. Mastercam created a profile for the solid. So I'm going to use the lower half of its profile. Start there, end here. Pick this tool, lower turret. Since I picked the lower side, it automatically knows I'm wanting to set it into the lower turret. Add a little bit to my lead out. Add a little extension. I'm going to turn on use stock for outer boundaries. And that's about it on this pass. It gives me a tool path. Oops. You want to go in and change. I don't want 100 thou depth cut. Let's stick with 50. Regen that. So now I have a roughing toolpath. So what I want to do with this roughing toolpath is I want to create a pinch toolpath since I have the availability of the upper turret. So we'll select the pinch turn. I'm going to select upper turret. Same thing, I still have to rotate my head down 90 degrees. Since I only have one rough operation, it's going to grab the only one available. I'm going to do a balance turn so it doubles my feed rate so my part gets done quicker. And I'm going to check on that. And there it does, creating me a toolpath for both these. The pinch toolpath is really nice to have, especially if you have dual turrets, only if you have dual turrets. So I'm going to go ahead and jump out of this Mastercam full file. And I'm going to jump into another one where I already have all of the toolpaths already created. So as you can see, all my operations are completed for the main spindle or the left spindle and the sub spindle or the right spindle. And we can program the right spindle because in the setup we created the right stock. So we don't have to wait to do the sub spindle work, and we can do it before we even consider doing the transfer. So all the operations are done. You can see I have my face, my pinch main, pinch associate. I have drill, mill the flats, mill the angle, spot all the holes, and drill the holes. And on my sub spindle, I have my roughing can, my finish can cycle, all coming from the lower, my contour profile, countersink 1/4 inch holes, and mill the chamfers on the front and back side of the flange. So all those are completed. My tools are already set up, so I can go to the tools setup manager, and you can see that I have in my upper turret, I have a turning tool with a turning tool holder. It's orientated with the insert down, working on the left spindle. If I wanted to use it on the right spindle, I just rotate my axis, my spindle, and I would have the insert up on the sub spindle. Lower turret has 2 tools. It has a rough and a finish tool, and I can use them on either spindle. So up for insert is up on the main spindle or the left spindle, insert be down on the right spindle. So also you can see that there's, my main WCS is always my machine group 1 WCS, and then there's different planes that were created for us when we did the setup. Mastercam created all these planes, which is really nice because it's all automated, and pretty much you pick the geometry and it decides what plane is going to be used based upon the geometry you're selecting. So this toolpath is a y-axis cross on the left-hand side, derived from geometry. The machine, so it picks this plane as your tooling plane. Real nice, don't have to figure it out. There's very few planes that you have to make yourself, which really streamlines the programming. So with that said, let's tackle the cutoff, bar pull, cutoff, and pickoff. So we'll start with the pickoff, stock pull, and cutoff. This is pretty much all automated too. You don't have to do a whole lot in here. Sometimes there's a little bit of tweaking here or there, but for the most part, you just screen check this, and it's going to populate all the operations you need to do a successful part off and transfer the part. Now I have everything I need to do a successful transfer of this part. And you'll notice that if I set the arrow here and I click the arrow down, it will show you the movement of the spindle and how it's going to grab the part and move it back into position as we go through this pick-off operations. So now that that's completed, I have to make sure that my cutoff tool is loaded. So we'll go over here and you'll see that the cutoff tool is not loaded. So I need a proper holder in one of the stations to be able to pick that off. I know I have one in here, so I'm going to grab the same one that I already have, LDI 1 inch. I'll put it up in the upper spindle. So now I have a floating holder there. I'm going to grab my part off tool, stick it on the station, and now I have my loaded part off tool. So now we'll go ahead and post this out to the code expert. You can see in my code expert that my operations are broken up into upper and lower stream. So my facing routine, my pinch turn associate, my pinch turn main, and my drill, and my finish turn. All these are coming from the bottom turret. All these are coming from the top turret. You can see my part off and all my synchronizations for the spindles and the clamping and the unclamping, the part off, and the final drilling and contour on the right spindle. So if I don't do anything here and I go straight into the launcher, you're going to see that it doesn't behave exactly like you want it to do. So we're going to turn off the housing. See my lower turret's loaded up, my upper turret's sitting parked. So now if I go ahead and run the simulation, you're going to see it's going to do the face and then it'll do the pinch turn. But because I didn't tell the lower turret to go first, it's going to crash. So we need to do a little bit more preparation here. Go back into Code Expert, and we're going to have to add some synchronization here into the operations. So I want the face to face the part, and I want it to pinch turn. I want the finish turn to finish before the drill approaches. So that will tell it to go face, pinch, finish, and then to drill. And then after the drill, I can go through the contour. I can finish all of the drilling, and I can go to this park point, this lathe point where it positions for the cutoff, and I can run a sync from there to this turret park. So I'm going to take and I'm going to go sync this one to for the tool change, and then I want to, so now it's going to go boom, 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 park the turret and stay there. Let's go through and it'll do finish with the left spindle. We will finish the synchronization, finish the cutoff, and then park upper reference. We will tie this to park lower reference. And then finish this lathe finish before we start the contour. So that there. So there's my synchronizations. So you can see it changed this from green to yellow, which means I have to save it. I can go back in, launch this, and you'll see a totally different behavior out of this machine. So now, should come in, face, pinch turn, should come in and do a finish pass, should drill and finish all the stuff on all the things on the main spindle. Looks like we need to stick out that tool a little bit farther. Make a little adjustment on how far that part's sticking out on the sub spindle. So let's go back to the sync manager. I'd like to add another sync in there because I didn't like the lower turret moving at the same time this sub spindle was coming up to do the pickoff. So let's add another part in there. Let's do it to this lathe point, and you can see my sync numbers are out of order now. I can just go renumber, and now they're all in order. You save that. Go back into the simulation. Let's see if it moves around a little better than previous. Pinch turn, finish turn, drill, cut the flats, spot drill, drill. See, now the turret is already parked before the sub spindle even moves into position. Those little things like that you can catch on the fly so that it doesn't happen when it goes out to the machine. Okay, so let's fix those two last little problems that we have there. We'll go back into Mastercam. I'm going to go back into the job setup. On the right spindle, the pickoff, right now it's at 2.75. So let's go to 3 inches. Let's move it out another 1/4 inch. And while we're at it, we saw that this 201 drill was hitting. So let's give it a little more out of holder length. Let's go 0.25, should be enough. Let's go and pick them all. We'll regen everything. All right, so now we can kick it back over to the Code Expert. Now that we're back into Code Expert, you can see all of our syncs stayed in the same place. So we can go back into the launch. Now we should see a clean simulation. So let's watch this run. Base pinch turn, finish turn, drill, mill the flats, spot drill, drill, Park the upper and lower turret. Bring out part off tool. Some spindle comes up, pulls part out. Parts. And off to the sub spindle. Rough. Finish. Build a profile. Spot the holes. And cut the chamfers. So basically you can catch all these little problems before it goes out on the floor, and you can be confident that you hand your machinist a good program that they'll be able to run without any problems. Now the other thing that's nice about this is because this is basically the same as your verify, I can go simulation, I can compare, and I can compare this part to my solid model, just like you can on the regular verify. So that's one of the nice things about mill-turn and single-stream environments. Let's go ahead and get out of that. Also, within the code expert, this is where a lot of the parameters are put that you can change the way the output of the code is. You can change the numbers, have them output or not output. You have a tailstock, how your reference codes come out. I can choose my coolant strategies, my reference positions, if I want optional stops or program stops at every tool change. So there's a lot of flexibility in here that you can use. So now that we got a clean simulation, let's go ahead and post out this program and see what it looks like. So you'll notice in the mill-turn environment, if I go to Multistream and I pick my program, it will split the program. The program's already split, but it will display the program with the upper turret and the lower turret. So now you can see this is the dual stream that you get from your mill-turn that you do not see in a single stream because it's only one program. I can align my synchronizations, so you can see when it comes up here, here's all the syncs for the pinch turn, and then my first sync here and here. So it kind of puts the program in perspective of what's actually running and when it runs. You can see there's space there where the lower turret doesn't run, but the upper does, and there's all my pickoffs. It's all my pickoff operations. Then there's my finished pickoffs, my finished synchronizations. So it gives you a lot of visibility on how the program is processed. So another feature I'd like to show you in Code Expert is this timeline feature that gives me the visibility of how the upper and lower stream are working together. So you can see in the upper stream, it runs all through the whole program. The whole program runs a little over 7.5 minutes. And you'll see the lower stream runs at the end, and there's a big gap between the end and the beginning. So from just over 1.5 minutes to just over almost 5.4 minutes, you can see that the lower turret isn't doing anything. So let's take a look at a different strategy on how to do this part. So let's jump into Mastercam. Let's grab the same part. I already have it programmed with a little bit different strategy. You can see my main spindle, all the operations are there. My sub spindle, all the operations are there. But I've chosen to put my pick off at the end of the operations. So my pick off cutoff will come last. So what that does, if we jump into code meter, is it gives me the ability to sync in the sync manager to sync these a little bit differently. So as you can see in the previous stream, I end with a contour and I end with a lathe finish. The park turret's here and the park turret's here. So that's different with this strategy. My end is the park turret. So let's see what that looks like in the simulation. Let's launch the simulation. And you'll notice right away in the timeline, you've gained about a minute's worth of time on this particular part. On a part that had a little more work being done with the lower turret, on the sub spindle, you would gain a lot more time. So let's see what this does. Let's watch this run. So we have the pinch turn. We have the finish turn. Now when the drill starts, now the lower turret's going to work on the sub spindle, while the upper turret's working on the main spindle. Gives you a little bit better utilization of the time on the machine. So just a little bit different strategy. Now you have a part in the main spindle and a part in the sub spindle at the beginning, rather than just a part in the sub spindle, or in the main spindle. And if we go back to code meter, you can see in the timeline that I've went to 6.27 seconds as opposed to 7.3 or 7.5. So we've saved a little bit of time here. So that ends this part of the demonstration. Let's jump into Singlestream. So now that we did our deep dive into the mill turn environments, let's take a look at a few of the Singlestream environments that are available. I got a part here. It's already programmed, just quick, easy, simple part. Kind of give you an illustration of what the single turn environments look like. So here I have a Haas ST20 with a Y-axis and a subspindle. So let's go ahead and look at what the launcher looks. Look what the simulation looks like. Okay, so pretty similar to the multi-stream. Just instead of more than one stream, you only have the one. Go to the launch, the simulation. See, even in the single stream, we have the full machine and all the bells and whistles. I can do full simulation. I can see collisions. Everything I can do in the mill turn environment, I can do in the Singlestream, except for sync operations because it's unnecessary in the Singlestream environment. So that was your Haas ST20 Y-axis machine. Let's jump out of there, go back into Mastercam. I have a Mori NLX 2500 MC. This is a single spindle lathe with a single turret. Let's look how this differs. Jump into Code Expert. Still, things pretty similar. I have parameters in here just like I have in the mill turn. I can vary my coolant strategies, change my reference points. So let's go ahead and launch this one. It's a little fun. It's fun to look at the same parts in a different environment. So there's the Mori housing and machine. Like I said, this is single turret with a single spindle and a tailstock. Let's see, run full simulation. Let's jump out of that one. Show you a couple more. Next one I have is a Kuma Genos L300, Y-axis capable, dual spindle, single turret. Let's jump into code meter. Same thing. Different, a little bit different, but still same overall. So let's launch the simulation. Take a look at this one. Full machine, full simulation. So last but not least, let's look at the Kuma 2600. This is also a Y-axis machine with a single spindle and an upper turret. Let's launch into Code Expert. Jump into the launcher. Into the simulation. See full housing, full machine, single spindle with a tailstock, upper turret. a part off. So in conclusion, what do we gain from a single stream or mill-turn environment? More efficient programs and programming, less machinist interaction, better visualization, and increased confidence.